The backrooms. 600 million square miles in space. That's pretty large. If a place like that were to exist, it might as well be infinite. Everything you see here is generated at runtime. The lights, the layout, anything unpleasant that might be lurking in the darkness. None of it exists until you press play. A labyrinth with no start and no end. For the past couple of years, I've been working on my own Backrooms game project. If you are unfamiliar, the Backrooms is an online community-driven concept. It is the idea that if you take the wrong step in the wrong place, you can fall through reality, or no-clip, and end up in a never-ending labyrinth of liminal space. It was first introduced in 2019 as a part of an online discussion about unsettling images. It was then further popularised by a YouTube filmmaker called Kane Parsons, who captured the attention of many people with his found footage series. I personally found it interesting and wanted to try my hand at bringing this environment to life in an interactive way. In the beginning, my project started out as just a bit of scrap code, an experiment to see if I could procedurally generate a game level that resembled other forms of Backrooms media. The longer I stuck with it, the more invested I became, until I finally achieved what I personally consider a large milestone: the illusion of infinite space. I've been a software developer for the past 10 years, working mostly on web applications. As a result, my tech stack for this project is using TypeScript. I have React for the UI, and Three.js as the graphics library. Three.js utilizes WebGL to render 3D graphics in the browser. It is by no means a game engine, so there is a little extra work required when using it to build a game. But the plus side is, you get a little bit more freedom with how you implement your mechanics. If I'm being really honest, I'm also very familiar with Three.js, so I didn't have to teach myself how to use it when starting this project. When I first discovered the Backrooms in 2022, I wanted to attempt to recreate the famous image that started it all. This is the result. And yeah, it's not very exciting, but this initial code commit marks the beginning of a very fun and educational journey. A lazy recreation of an old photo is one thing, but what about an explorable environment? Well, I decided in my Backrooms game that I would use a tile-based approach. Each tile would be 10 units in width and 10 units in length, and would sit side by side with one another. They would also have, at the very least, a floor and a ceiling. Some might have a light, and some might have walls. I could then use this approach to construct different environments. In the early days, I manually placed them side by side, but this was not procedural. Then I tried building a room and placing tiles randomly within it, but this was not interesting. I quickly learned that I needed a data structure that would be the blueprint for how these tiles were placed, and what should render within them. I started researching different ways to generate procedural grid data that could be used to map my tiles into 3D space. This led me to an article by the author Ahmed Abdelsaheb on Free Code Camp. It provides a detailed outline for creating procedural dungeons using the random walker algorithm. I will leave a link below for anyone who might be interested in checking it out. It's a great read and goes into detail about how this algorithm works. For now, however, I'll give you the non-technical breakdown and some of the modifications I implemented in my project. We start off with a blank grid. Each cell has a value of 1, which means it is closed. The algorithm will pick a starting cell somewhere on the grid and give that cell a value of 0, which means it is now open. It then carves through a random number of cells in a random direction and opens up any cell it encounters. It chooses a new direction and carves through another random amount of cells. This process continues until it has carved through the provided number of tunnels. I also added a tunnel width property, so it can carve wider tunnels, as well as some padding so it carves within an area. This will leave some space for connecting tunnels later. You may have noticed some yellow cells. That's because when each cell is being carved, it has a 12% chance of receiving a light. Now we have all the information we need to build our first procedural level with tiles. Open cells get their floor and ceiling. Cells flagged as having a light get a light, and walls are used to hide all the closed cells away from the open. When I first organized my tiles this way, I looked into adding some basic player controls using the Three.js pointer lock controls add-on. This allowed me to walk around my first procedurally generated level, and I have to say, this was one of those programming dopamine spike moments. You finally place a piece of the puzzle and can allow yourself a moment to just sit and admire it. After running around a bunch of empty hallways, it was time to get back to work. The idea of an endless labyrinth was something I wanted to achieve. However, I still had many optimizations and tricks to learn before I could tackle that task. I decided to start small and add an elevator loop. You start in a series of hallways, find the elevator, and it takes you to another series of hallways. I then changed the Walker algorithm properties to create some variety. While this did work, I felt like it was not enough, so I added a few more algorithms to produce different types of grids. There is the room and corridor algorithm, which has quite a lot of potential. Then there are more cave-like algorithms that produce open spaces. Caves can also link together with corridors. If you watch the fan-made backrooms videos online, they generally start off in the usual yellow wall partition space. Over time, they start to reveal other spaces. These spaces include different walls, floors, ceilings, and lights. Sometimes they'll even shock you with a sense of overwhelming scale. This is important. It adds extra character to the backrooms concept, and it also keeps people engaged when watching a film or playing a game. As a result, I began setting up a styling manager. I can now create preset style configs that control the color and feel of each level. It can also control which types of lights to use and on which types of ceilings they should appear. Each surface can now use textures. These include color mapping, normal mapping, specular mapping, and more. I can define the default level height and thickness, and whether to use angled walls where appropriate. This gives us more variety. Later we can drip feed these changes to the player in a way that keeps them curious and wondering what comes next. One of the things I like about the backrooms is just how bizarre it can be. There are holes in the wall and floor. Some walls can be recessed or have bulkheads for no particular reason. If I want to include these kinds of details, I need a way for each cell to describe how it should look. We have our default level styles, which will apply for every cell, but now we need to try and override them for some more localized variants. I decided to add a few more properties to my cells. Now I can elevate or lower the floor, I can elevate or lower the ceiling, I can tell certain surfaces to behave like other surfaces, and I can render a different type of light other than the default. The best part is the algorithm can apply these properties while it is constructing the level. which gives me the freedom to place these overrides for entire sections, as well as combining certain effects for interesting results. One of the main problems that I faced early in development was the lighting. I could create an entire episode on that topic alone, which may come next, so I'll keep my explanation brief here. To put it simply, the more lights you have in a scene, the more work a GPU has to do. So you can imagine the toll a place like the backrooms would take. I was able to solve this with a custom shader that can apply the baked lighting data that is stored on the geometry's vertex buffer, with a baking pipeline that doesn't block the main render loop. This allowed me to proceed to the final step towards an endless labyrinth. I started researching a technique called chunking. Chunking is the process of dividing a game world into pieces. The game can hide and reveal these pieces to the player based on their proximity to them. The reason for this is performance. You usually can't afford to have your entire game world rendered at once, especially if the intention is for it to be an endless world. Considering my engine can produce a variety of grid-driven environments, chunking felt like the natural step toward creating the illusion of infinite space. When I generate a space, I make sure to also prepare grids for the north, south, east, and west sides. I draw some connecting tunnels to the edge of each grid, and then I connect these tunnels to allow traversal. When a player enters a new chunk, the engine will create any extra chunks that aren't already there. We can then hide all the areas that the player is not near, and reveal them when the player gets closer. Since adding the chunks, the player now spawns into the Genesis chunk at coordinate 0, 0. They then face a choice of 4 different directions. These are the connecting tunnels mentioned earlier. At this point, the chunking toggle is not always subtle, but I am currently working on a more seamless solution. We also get some slight frame rate dips when crossing into a new chunk due to the runtime generation, but with time, I will be able to optimize this process even further to reduce the performance hit. The player at this stage is free to explore my endless backrooms labyrinth. They will encounter different layouts, a sudden change in environmental style, strange and unpredictable structural designs, furniture placed in a random arrangement, as well as stable lighting, unstable lighting, and low visibility lighting. Regarding gameplay, I still need to develop some of the systems I have planned. I'm looking to encourage exploration with some survival mechanics. Hunger and thirst mean the player must find food and water, but they might also face some dangers along the way. I still need to add sound, and there are more features I'd like to add for the environment as well, such as a bit more verticality and a sense of progression. I still have plenty of work to do. The procedural environment felt like one of the biggest challenges, so having a strong foundation for it feels great. It makes the end goal seem much closer. I hope you enjoyed watching this devlog, and I look forward to revealing more about this project as time goes on. Until then, take care, and thanks for watching.